If you look at almost every mammal on Earth, one thing becomes immediately obvious. They are covered in hair. From lions in the savannah, to bears in icy forests, to even our closest relatives like chimpanzees and gorillas, body hair is a basic survival feature. It protects against cold. It shields the skin from sun. It helps with camouflage. And it even plays a role in sensing the environment. But humans are different. Very different. Compared to almost every other mammal, humans appear almost naked. We have only fine body hair in most areas, with thicker hair mostly limited to the head, eyebrows, and a few other regions. This makes humans one of the most unusual species in the animal kingdom. And it raises a powerful question. Why did we lose our body hair? To understand this mystery, we first need to compare ourselves with our closest relatives in nature. Chimpanzees and bonobos, who share a common ancestor with humans, still carry dense body hair across their entire bodies. Their fur is not just for appearance. It is essential for survival in forests, where temperature changes, insects, and physical protection all matter. Gorillas, orangutans, and other primates also rely heavily on their fur for insulation and survival. But at some point in evolutionary history, humans took a completely different path. Instead of becoming more hairy for protection, we became less hairy. Instead of relying on fur, we began relying on something else entirely. But what exactly changed? This is where the mystery begins. At first glance, losing body hair seems like a disadvantage. Without thick fur, humans are more exposed to sunlight, cold weather, and environmental stress. In evolutionary terms, losing a protective feature should make survival harder, not easier. Yet humans not only survived, we thrived. We expanded into deserts, forests, mountains, and eventually every corner of the planet. This contradiction is what makes the question so fascinating. Because evolution usually does not remove useful traits without a reason. Every change in the body typically serves a purpose, either improving survival or supporting reproduction. So why would natural selection favor hairless skin in humans? Scientists have been debating this question for decades. And even today there is no single agreed answer. Instead, there are several competing theories. Some researchers believe body hair was lost to help humans stay cool in hot African environments. Others suggest it was related to parasite control, making early humans healthier. Another group points towards sexual selection, where smooth skin may have been considered more attractive over time. There are even more controversial ideas, such as semi-aquatic adaptation theories, which suggest early humans may have spent time in water-rich environments. Each theory explains part of the puzzle, but none explain everything perfectly on their own. This is why the mystery still exists. Human evolution is rarely simple, and the story of body hair loss is no exception. It is not a single event, but likely a combination of many factors working together over millions of years. Climate changed, behavior changed, technology emerged, and survival strategies evolved. Slowly, generation by generation, humans became less dependent on natural body insulation and more dependent on intelligence, cooperation, and tools. But before we explore each of these theories in detail, we must first go back in time. Way back. To a world where our ancestors were not hairless at all, but fully covered in thick fur, moving through ancient forests as just another primate species among many. That is where the story truly begins. Long before humans built cities, sailed oceans, or even discovered fire, our ancestors lived in a world that looked very different from the one we know today. Millions of years ago, the earliest members of the human family inhabited the forests of Africa. These ancient hominins were not the hairless creatures we recognize as human today. Instead, they were covered from head to toe in thick body hair, much like the great apes that still inhabit parts of Africa and Asia. If you were somehow able to travel back in time and observe them, you might not immediately recognize them as members of your own family tree. Their bodies were adapted for a life spent among trees, dense vegetation, and constantly changing natural environments. Thick fur was not unusual. In fact, it was one of the most valuable survival tools they possessed. For these early ancestors, body hair served many important purposes. First and most obviously, it provided insulation. Temperatures in prehistoric environments could vary significantly between day and night. While Africa is often imagined as endlessly hot, many regions experience surprisingly cool nights. A layer of fur helped trap body heat and maintain a stable temperature. This natural insulation allowed early hominins to remain active and survive without clothing, shelter, or artificial heat sources. Fur also offered protection from the environment itself. Branches, thorns, insects, and rough vegetation were common hazards in forest habitats. Thick body hair created a protective barrier between delicate skin and the outside world. Even minor injuries could become dangerous in prehistoric conditions, making every layer of protection valuable. Another important benefit was camouflage. In dense forests filled with shadows and filtered sunlight, fur helped animals blend into their surroundings. Remaining unnoticed could mean the difference between life and death. Predators hunted constantly, and avoiding detection was often safer than confrontation. For millions of years, fur worked exceptionally well. There was little reason for evolution to change something that was already helping our ancestors survive. When scientists compare humans with our closest living relatives today, the contrast becomes striking. Chimpanzees, our nearest genetic cousins, still possess dense body hair covering nearly their entire bodies. Gorillas, orangutans, and bonobos display similar characteristics. Although the exact thickness and appearance vary between species, the basic pattern remains the same. Among primates, being covered in fur is normal. Being mostly hairless is unusual. This fact alone makes human evolution one of the great mysteries of biology. Because when we look at the evolutionary family tree, humans appear to be the exception rather than the rule. Imagine standing beside a chimpanzee. Both species share a common ancestor that lived millions of years ago. Our skeletal structures are surprisingly similar. Our hands, eyes, facial expressions, and even many behaviors reveal this shared heritage. Yet one difference immediately stands out. The chimpanzee is covered in thick hair. The human is not. Somewhere along the long path of evolution, something changed. But at this stage of the story, that change had not yet begun. The earliest hominins remained fully furred creatures, perfectly suited to the environments they inhabited. Their forests provided food, shelter, and relative protection from the intense sunlight found in more open landscapes. Hair helped regulate temperature, reduced physical injuries, and contributed to overall survival. From an evolutionary perspective, fur was a successful adaptation. No scientist looking at these ancient ancestors would predict that their descendants would someday become one of the least hairy mammals on Earth. Yet evolution often follows unexpected paths. The environments that shaped these early hominins would not remain the same forever. Over time, powerful climatic changes would begin transforming Africa itself. Forests that had dominated the landscape for countless generations would slowly shrink. In their place, vast open grasslands would emerge. And as our ancestors left the shelter of the forests and stepped into a hotter, more exposed world, the advantages of thick body hair would begin to change. The next chapter of the mystery starts not with humans themselves, but with a changing planet, one that would force our ancestors to adapt in ways no one could have imagined. For millions of years, our ancestors lived beneath the protective canopy of African forests. The trees provided shade from the sun, shelter from predators, and a relatively stable environment in which thick body hair remained a valuable survival tool. But nature is never static. Slowly, over vast stretches of time, Africa began to change. Powerful climatic shifts altered rainfall patterns across the continent. Regions that had once been covered by dense forests gradually became drier. Trees retreated. Woodlands shrank. Open grasslands expanded across the landscape. The transformation did not happen overnight. It unfolded over hundreds of thousands, even millions of years. Yet the consequences for our ancestors were enormous. As forests disappeared, early hominins found themselves facing a completely different world. Instead of moving beneath cool shade, they now spent increasing amounts of time in open environments exposed directly to the African sun. This new landscape offered opportunities, but it also introduced serious challenges. The savanna was vast and unforgiving. Food sources were spread over larger distances. Water could be difficult to find. Predators could be spotted from far away, but they could also spot you. Survival now required movement on a scale that forest life had never demanded. Our ancestors had to travel farther in search of food, water, and safety. And with every step taken beneath the scorching sun, a new problem emerged. Unlike forests, open grasslands offered little protection from direct sunlight. During the hottest parts of the day, temperatures could become extreme. The same body hair that had once provided insulation and protection now carried an unexpected disadvantage. It trapped heat. For an animal living in constant shade, this was not a major issue. For an animal walking across open savannas, it could become a serious threat. Overheating is one of the most dangerous challenges any creature can face. When body temperature rises too high, physical performance declines. Energy levels fall. Decision-making becomes impaired. In extreme cases, overheating can lead to death. Natural selection tends to reward traits that improve survival. And in the changing landscapes of Africa, individuals who could remain cooler during long periods of activity may have possessed a significant advantage. Scientists believe this environmental pressure may have played a major role in shaping the future of human evolution. As generations passed, even small differences could matter. An individual with slightly less body hair might lose heat more efficiently. That individual could remain active longer during hot days. They might travel farther in search of food. They might escape danger more effectively. And ultimately, they might be more likely to survive and pass their genes to future generations. Evolution rarely works through dramatic changes occurring all at once. Instead, it often proceeds through countless small advantages accumulating over immense periods of time. A little less hair. A little better cooling. A slightly higher chance of survival. Then the process repeats again and again. As these pressures continued, the relationship between humans and their environment began to change. Our ancestors were no longer creatures primarily adapted for forest life. They were becoming specialists of the open landscape. This transition influenced more than just body hair. It encouraged new forms of movement, new feeding strategies, new social behaviors, and eventually entirely new ways of surviving. The savanna rewarded endurance rather than short bursts of speed. It favored animals capable of traveling long distances under difficult conditions. And among all the creatures adapting to this changing world, the human lineage began developing a remarkable advantage. An ability that would eventually help our ancestors dominate environments across the globe. But this advantage depended on solving the heat problem. Reducing body hair alone was not enough. The body also needed a way to actively remove excess heat while remaining in motion. Fortunately, evolution had another solution waiting. A solution so effective that it would become one of humanity's greatest biological superpowers: the ability to sweat. And it is this extraordinary cooling system that may explain why losing body hair became one of the most important adaptations in human history. As our ancestors adapted to life on the open African savanna, they faced a challenge that would shape the future of human evolution. The challenge was heat. Day after day, beneath the relentless African sun, early humans traveled across landscapes far more exposed than the forest their ancestors had once called home. The problem was not simply surviving predators or finding food. It was preventing their own bodies from overheating. For most animals, excess heat is a serious limitation. When body temperature rises too high, muscles become less efficient. Energy levels drop. The risk of exhaustion increases dramatically. In extreme cases, heat can become deadly. Nature has developed many ways to solve this problem. Dogs pant. Elephants flap their enormous ears. Many mammals seek shade during the hottest hours of the day. But humans evolved something truly extraordinary. A cooling system unlike almost any other large mammal on Earth. The ability to sweat. Today, sweating may seem ordinary. Most people think of it as little more than an inconvenience on a hot day. But from an evolutionary perspective, sweating may have been one of humanity's greatest biological innovations. In fact, some scientists believe it helped transform our ancestors into one of the most successful species the world has ever seen. The human body contains millions of sweat glands. These tiny structures are distributed across nearly the entire surface of the skin. When body temperature begins to rise, the brain sends signals that activate these glands. They release water onto the skin. At first glance, this may not seem particularly impressive. But what happens next is the key. As sweat evaporates into the surrounding air, it carries heat away from the body. This process creates a natural cooling effect. Every drop of evaporating sweat removes a small amount of heat. Millions of drops working together can lower body temperature remarkably efficiently. This cooling mechanism is based on a simple principle of physics. Water requires energy to change from a liquid into a gas. When sweat evaporates, it takes that energy from the heat stored in the skin. As a result, the body cools down. It is an elegant solution. And it allowed humans to remain active in conditions that forced many other animals to rest. However, there was a problem. Sweating works best on exposed skin. Dense body hair interferes with evaporation. Imagine pouring water onto a thick wool blanket. Much of the moisture becomes trapped within the fibers. Air circulation decreases. Evaporation slows. The cooling effect becomes less efficient. The same principle applies to fur-covered animals. Thick body hair can trap moisture close to the skin, reducing the effectiveness of evaporative cooling. For early humans living under intense heat, this created a powerful evolutionary pressure. Individuals with slightly less body hair could potentially cool themselves more efficiently. Their sweat evaporated more easily. Their bodies released heat more effectively. and they could remain active longer than individuals carrying thicker coats of fur. Over thousands of generations, this small advantage may have become increasingly important. Natural selection rewards traits that improve survival. And in a hot environment where overheating could mean death, better cooling offered a major advantage. Scientists often describe humans as endurance specialists. We are not the fastest animals. We are not the strongest. We do not possess claws, fangs, or thick protective hides. Yet we excel at something few animals can match. We can remain physically active for very long periods of time. Much of this ability depends on temperature control. A body that overheats quickly cannot sustain prolonged activity. A body that remains cool can continue moving, searching, hunting, and surviving. The evolution of sweating gave humans a unique edge. While many predators rested during the hottest parts of the day, our ancestors could continue traveling across the landscape. While other animals struggled with rising temperatures, humans developed a cooling system capable of operating for hours. This may have fundamentally changed the way early humans interacted with their environment. Rather than avoiding heat entirely, they learned to function within it. And this adaptation may have unlocked entirely new survival strategies. Long-distance travel became easier. Food resources spread across vast areas became more accessible. New habitats could be explored. Over time, the combination of reduced body hair and efficient sweating transformed the human body into a remarkable heat management machine. Of course, evolution rarely acts for only one reason. Hair loss likely involved multiple factors working together. But among all the theories scientists have proposed, the connection between sweating and heat control remains one of the strongest. The evidence fits the environment. It fits human physiology. And it helps explain why our species followed a path so different from our primate relatives. Yet cooling the body was only part of the story. Once humans gained the ability to stay active under extreme heat, they began using that advantage in unexpected ways. Ways that would allow them to compete against animals far faster and stronger than themselves. The next chapter takes us into one of the most fascinating ideas in human evolution. The possibility that humans became hunters not because we were powerful, but because we simply refused to stop running. For most of human history, survival depended on a simple challenge: finding enough food. Long before supermarkets, agriculture, or domesticated animals, our ancestors lived in a world where every meal had to be earned. Hunting was often dangerous, exhausting, and uncertain. Early humans lacked many of the natural weapons possessed by other predators. They had no sharp claws, no powerful fangs, no incredible speed. A lion could outrun them. A leopard could overpower them. A wolf could track prey with a far superior sense of smell. At first glance, humans seemed poorly designed for hunting. Yet somehow they became one of the most successful predators on Earth. The secret may not have been strength or speed. It may have been endurance. Among scientists, there is a fascinating idea known as persistence hunting. This hunting strategy relies on something surprisingly simple. Instead of catching prey quickly, hunters pursue it slowly but relentlessly over long distances. The goal is not to outrun the animal. The goal is to outlast it. Imagine a hot afternoon on the African savanna tens of thousands of years ago. A small group of hunters spots an antelope grazing in the distance. The animal is far faster than any human. If it senses danger, it can sprint away in seconds. And that is exactly what happens. The antelope bolts across the grasslands. For most predators, the hunt would end there. But the humans do not stop. They continue following. Not at full speed. Not in a desperate sprint. But at a steady pace they can maintain for hours. The antelope slows down and begins to recover. Then the humans appear again. The animal runs once more. Again and again the cycle repeats. Each time the prey escapes, it is forced to generate tremendous amounts of heat through intense physical activity. And eventually heat becomes the real enemy. Many mammals are excellent sprinters. But sprinting comes with a cost. Large amounts of body heat are produced during rapid movement. Unlike humans, many animals have limited ways of cooling themselves efficiently while running. They often rely on panting, which becomes difficult during intense exertion. As body temperature rises, exhaustion begins to set in. Meanwhile, the human hunters continue moving. Their pace is slower. But their cooling system keeps working. Sweat evaporates from their skin. Heat escapes into the surrounding air. Their bodies remain within a manageable temperature range. Hour after hour, they continue the pursuit. Eventually, the prey reaches its limit. Its muscles weaken. Its body temperature climbs dangerously high. It can no longer escape. And when the hunters finally catch up, the exhausted animal is vulnerable. This strategy may sound unusual today, but evidence suggests that persistence hunting was practiced by some human societies well into modern times. Anthropologists have documented hunters using similar methods in parts of southern Africa, demonstrating that the technique is not merely theoretical. It is a real survival strategy, and it highlights one of the most remarkable advantages humans possess: the ability to remain active under heat stress for exceptionally long periods. This is where the story of body hair becomes important once again. Persistence hunting would have been far more difficult if our ancestors remained covered in thick fur. Every step generates body heat. Every mile increases physical strain. Efficient cooling becomes essential. Hairless skin allows sweat to evaporate more freely. Heat escapes faster. The body avoids dangerous overheating. In this way, reduced body hair may have directly contributed to hunting success. A hunter who stayed cooler could continue the chase longer. A hunter who cooled efficiently could cover greater distances. Over many generations, these advantages could influence survival and reproduction. Natural selection would gradually favor traits that improved endurance performance. And endurance became one of humanity's defining characteristics. When we think about evolution, it is tempting to focus on dramatic features: sharp teeth, powerful muscles, massive size. But sometimes the most important adaptations are subtle. The ability to regulate body temperature may have changed human history more than any claw or fang ever could. By solving the heat problem, our ancestors unlocked a completely new way of interacting with the world. They could travel farther, explore larger territories, track animals across great distances, and compete with predators that were physically superior in many other ways. This endurance advantage may have helped shape the rise of humanity itself. Of course, endurance hunting was not the only force influencing body hair loss. Other factors were also at work. As humans became increasingly intelligent, they began developing technologies that further reduced their dependence on natural body insulation. And among those technologies, none would prove more important than one of the greatest discoveries in human history: fire. Fire. For millions of years, animals relied on their bodies for protection. A thick coat of fur could provide warmth during cold nights. It could shield the skin from wind and rain. It could help an animal survive changing seasons without needing to build anything or carry anything. Protection was built directly into the body. But humans were beginning to take a different path. As our ancestors evolved, they developed something far more powerful than thicker fur or stronger skin. They developed technology. And among all the technological breakthroughs in human history, few were as important as the discovery of fire. No one knows exactly when humans first learned to control fire. Evidence suggests that early human species were using fire hundreds of thousands of years ago, and perhaps even earlier. At first, fire may have come from natural sources such as lightning strikes or wildfires. Eventually, humans learned how to maintain it, transport it, and later create it themselves. This changed everything. For the first time, warmth no longer had to come from the body alone. Instead of depending entirely on natural insulation, humans could sit beside a fire and receive heat from an external source. On cold nights, flames provided protection against falling temperatures. In harsh environments, fire created small islands of warmth in an otherwise dangerous world. This was a revolutionary development. Because every animal must solve the same basic problem: how to stay warm when conditions become cold. Most species solve it biologically. Humans increasingly solved it technologically. A bear grows a thicker coat. A human builds a fire. As fire became a regular part of daily life, the pressure to maintain dense body hair may have decreased. The environment had changed once again, not because nature changed but because humans changed it. For perhaps the first time in evolutionary history, a species was actively altering its surroundings to improve survival. And fire offered more than warmth. It provided protection from predators. Many dangerous animals avoided flames, making campsites safer places to rest. Fire also extended the usable hours of the day. Activities could continue after sunset, strengthening social bonds and cooperation. Most importantly, fire transformed food. Cooking made many foods easier to digest and safer to eat. More calories became available from the same resources, helping support larger brains and increasingly complex societies. But alongside fire came another innovation that would further reduce humanity's dependence on fur: clothing. At some point, early humans began covering themselves with animal skins and other materials. The exact timing remains debated, because clothing rarely survives in the archaeological record. Yet scientists agree that clothing eventually became an essential part of human life. This innovation achieved something remarkable. Instead of growing protection naturally, humans could manufacture it. Animal skins could provide warmth equal to or greater than fur. But unlike natural body hair, clothing could be removed when temperatures rose and added when temperatures fell. It offered flexibility. And flexibility became one of humanity's greatest strengths. A fur coat is permanent. Clothing can change with circumstances. This allowed humans to move into environments that would have been impossible for a mostly hairless species to survive otherwise. Cold mountains, northern forests, frozen landscapes. Wherever humans traveled, clothing traveled with them. As human intelligence advanced, shelters also became increasingly important. Early hominins may have relied on caves and natural formations for protection. Later, humans began constructing simple shelters using branches, animal hides, and other available materials. These structures provided protection from wind, rain, and temperature extremes. Once again, technology was replacing biology. Instead of evolving thicker fur for colder conditions, humans built homes. Instead of growing insulation, they created it. This pattern would continue throughout history. The human story became less about adapting the body and more about adapting the environment. Many scientists believe this shift helps explain why body hair continued to decline. Natural fur was no longer the only solution to cold weather. Fire could provide warmth. Clothing could provide insulation. Shelters could provide protection. Together, these innovations reduced humanity's dependence on the biological advantages that other animals still relied upon. And as humans became increasingly skilled at shaping the world around them, evolution began rewarding not just physical traits, but intelligence, creativity, and cooperation. The body was changing, but so was the mind. And in the next chapter, we explore another surprising theory about body hair loss, one involving some of humanity's oldest and most persistent enemies, tiny creatures hiding among the fur. While heat, sweating, and endurance hunting provide compelling explanations for why humans may have lost much of their body hair, some scientists believe another powerful force was also at work. A force much smaller than a lion. Smaller than a spear. Smaller than a grain of rice. Parasites. For millions of years, mammals have shared the world with tiny creatures that depend on them for survival. Fleas, ticks, lice, mites, and countless other parasites have evolved alongside animals, feeding on blood, skin, and other resources provided by their hosts. To these organisms, a thick coat of fur is not just hair. It is a home. Dense body hair creates a warm, protected environment where parasites can hide, reproduce, and avoid detection. For many species, fur provides ideal living conditions. And where parasites thrive, problems often follow. At first glance, a few fleas or lice might seem like little more than an annoyance. But throughout evolutionary history, parasites have represented a serious threat to survival. They can weaken their hosts by feeding on blood. They can cause skin infections through constant irritation. And perhaps most importantly, they can spread disease. Today, we often think of diseases as being caused by viruses and bacteria. Yet many diseases reach their victims through insects and parasites that act as carriers. Ticks can transmit dangerous infections. Fleas have historically spread devastating epidemics. Lice can carry harmful pathogens from one host to another. In prehistoric environments where medicine did not exist, even relatively minor infections could become life-threatening. This has led some researchers to propose an intriguing idea. What if losing body hair helped humans reduce their parasite burden? Imagine two early humans living in the same environment. One possesses a thick coat of body hair. The other has slightly less. The individual with less hair may offer fewer places for parasites to hide. Lice become easier to spot. Ticks become easier to remove. Fleas have fewer protected areas in which to reproduce. Over time, this difference could translate into improved health and survival. Natural selection does not require enormous advantages. Even small improvements can matter when repeated across thousands of generations. A slightly healthier individual may have more energy. A slightly healthier parent may raise more surviving children. And those small advantages accumulate over time. The parasite theory becomes even more interesting when combined with another uniquely human behavior: social grooming. Among many primates, grooming is an essential part of daily life. Chimpanzees groom one another. Monkeys groom one another. Removing parasites from a companion's fur helps maintain health while also strengthening social bonds. Early humans likely engaged in similar behaviors. However, as body hair became thinner, grooming may have become even more effective. Parasites hiding in dense fur can be difficult to find. Parasites on relatively exposed skin are easier to detect and remove. In this way, reduced body hair and social grooming may have worked together. Less hair made parasites easier to identify. Grooming helped remove them. Together, these behaviors could improve overall health within a group. Some scientists argue that this combination may have created significant evolutionary pressure favoring reduced body hair. There is also evidence from modern parasites themselves. Human lice are surprisingly specialized creatures. Researchers studying the evolution of lice have discovered that different species occupy different regions of the human body. Head lice and pubic lice, for example, evolved to live in distinct environments. Some scientists believe these patterns may provide clues about when body hair began disappearing during human evolution. The fact that humans retain dense hair primarily on the scalp and in a few other regions may not be entirely coincidental. These remaining areas still provide suitable habitats for specialized parasites today. Of course, the parasite theory is not universally accepted as the sole explanation for human hair loss. Like many aspects of evolution, the answer is likely more complicated. Parasite reduction alone may not fully explain why humans became so much less hairy than other primates. But when combined with the pressures of heat regulation, sweating, and endurance hunting, it becomes part of a larger picture. Evolution often works through multiple forces acting simultaneously. A trait may survive because it provides several advantages at once. Less body hair may have helped humans stay cool. It may have improved hunting success. And it may also have reduced the burden of parasites and disease. Together, these benefits could have reinforced one another across countless generations. Yet there is another theory that takes the story in a very different direction. A theory that has less to do with survival, and more to do with attraction. Because evolution is not driven only by staying alive. It is also shaped by who chooses to reproduce with whom. And that possibility opens the door to one of the most fascinating ideas in the entire. Not every evolutionary change happens because it improves survival. Sometimes, traits spread through a population for a different reason. They make an individual more attractive to potential mates. This process is known as sexual selection, and it has shaped some of the most remarkable features in the animal kingdom. Consider the peacock. Its enormous colorful tail does not help it escape predators. In fact, the tail can make survival more difficult. Yet peacocks continue to evolve these spectacular displays because peahens often prefer males with larger, more impressive feathers. Over many generations, attraction influences evolution. Some scientists believe a similar process may have played a role in the loss of human body hair. The idea begins with a simple observation. Skin reveals information. When much of the body is covered by thick fur, it becomes harder to see signs of health and physical condition. But when skin is exposed, certain clues become much more visible. Healthy skin can indicate youth. It can reveal the absence of parasites. It can show freedom from infections or injuries. In a prehistoric world where survival depended heavily on health and physical fitness, these signals may have been important when choosing a mate. Imagine two potential partners living tens of thousands of years ago. One appears heavily infested with parasites hidden beneath dense body hair. The other has smoother skin with fewer visible signs of disease. Even without conscious understanding, individuals may have preferred partners who appeared healthier. If such preferences existed, they could influence reproduction over many generations. Natural selection favors survival. Sexual selection favors attractiveness. Sometimes the two forces work together. In this case, smoother skin may have communicated valuable information about overall health. Some researchers suggest that reduced body hair made it easier to evaluate a potential mate's condition. Healthy skin could serve as an honest signal that an individual was relatively free from disease, parasites, or other health problems. As preferences accumulated across generations, less body hair could gradually become more common within the population. Of course, proving such ideas is difficult. Unlike fossils or ancient tools, mating preferences rarely leave physical evidence behind. Scientists cannot travel back in time to observe exactly what our ancestors found attractive. For this reason, the sexual selection theory remains one possibility among several rather than a definitive answer. Yet many experts believe it may have contributed to the overall process. Evolution often operates through multiple influences at once. Heat regulation may have encouraged hair loss. Parasite reduction may have reinforced it. And mate preferences may have accelerated it. Together, these pressures could have pushed human evolution in the same direction. There is also an interesting cultural dimension to the story. Throughout history, different societies have developed their own ideas about beauty, appearance, and grooming. Although standards vary widely across cultures and time periods, humans have consistently paid close attention to hair, skin, and physical appearance. This does not prove that sexual selection caused body hair loss, but it highlights how strongly appearance can influence human behavior. Even today, hair remains deeply connected to identity, attraction, and social perception. The sexual selection theory reminds us that evolution is not driven solely by survival in harsh environments. It is also shaped by relationships, preferences, and social interactions. But not every explanation for human hair loss has received widespread scientific support. One theory in particular captured public imagination for decades because it offered a dramatically different answer. An answer involving water. And a controversial idea known as the Aquatic Ape Hypothesis. Among all the theories proposed to explain why humans lost much of their body hair, few are as controversial, or as fascinating, as the aquatic ape theory. Unlike explanations based on heat regulation, parasites, or sexual selection, this idea suggests something far more unusual. What if our ancestors spent significant time living in and around water? The theory first gained attention during the 20th century and proposed that at some point in human evolution, early hominins may have adopted a semi-aquatic lifestyle. According to supporters of the hypothesis, this period near lakes, rivers, wetlands, or coastlines may have influenced several unique human traits. One of those traits was body hair loss. The argument was inspired by comparisons with certain aquatic mammals. Animals such as whales, dolphins, and manatees possess very little body hair. Living in water makes thick fur less useful for some species, and streamlined skin can reduce drag while swimming. Supporters of the aquatic ape theory suggested that something similar may have happened to human ancestors. They pointed to several features of the human body. Humans possess a layer of body fat beneath the skin that differs somewhat from many other primates. We are relatively hairless compared with chimpanzees and gorillas. Humans can voluntarily hold their breath for short periods. We are also comfortable swimming, even though we are not specialized aquatic animals. To advocates of the theory, these characteristics seem to hint at a possible aquatic phase in our evolutionary past. The idea captured public imagination because it offered a dramatic alternative to more conventional explanations. It painted a picture of ancient humans wading through wetlands, gathering food from shallow waters, and gradually adapting to life along aquatic environments. For many people, it was an exciting possibility. However, most scientists remain unconvinced. The primary problem is evidence. Science depends on data that can be tested and verified. While the aquatic ape theory is imaginative, researchers have found very little fossil or archaeological evidence supporting the existence of a prolonged semi-aquatic stage in human evolution. The human fossil record largely points toward adaptation to terrestrial environments rather than aquatic ones. Features such as upright walking, endurance movement, and heat regulation appear closely connected to life on land. Many traits cited by supporters of the theory can also be explained more convincingly through other evolutionary processes. For example, reduced body hair fits well with the sweating and heat control hypothesis. Body fat distribution may be influenced by energy storage needs and other factors unrelated to aquatic living. The ability to swim does not necessarily require an aquatic ancestry, just as the ability to climb does not make humans tree specialists today. As a result, the aquatic ape theory is generally regarded as a fringe hypothesis rather than a mainstream scientific explanation. Most evolutionary biologists do not consider it a likely solution to the mystery of human hair loss. Yet the theory has never completely disappeared. Part of the reason is that it tells a compelling story. Humans are naturally drawn to unusual ideas, especially when they challenge established explanations. The image of semi-aquatic ancestors navigating ancient shorelines captures the imagination in a way that discussions of sweat glands and climate change sometimes do not. And science itself benefits from questioning assumptions. Even theories that are ultimately rejected can encourage researchers to examine evidence more carefully and test new possibilities. Today, the aquatic ape theory serves as a reminder that not every popular idea becomes scientific consensus. Some hypotheses survive because they are supported by evidence. Others survive because they are memorable. As we continue exploring the mystery of human hair loss, the evidence increasingly points toward a combination of factors rather than a single dramatic cause. And that raises another important question. If losing body hair provided advantages, did it come with costs as well? Every evolutionary advantage comes with a cost. The story of human hair loss is no exception. While reduced body hair may have helped our ancestors stay cool, hunt more effectively, and possibly reduce parasites, it also created new challenges that had to be overcome. For millions of years, fur had served as a natural shield. It protected against cold temperatures. It reduced exposure to wind and rain. It provided a layer of defense against sunlight and minor injuries. As humans gradually lost much of this protection, they became more vulnerable to the environment. A hairless body cools efficiently in hot conditions, but it also loses heat more quickly when temperatures drop. This created a serious problem. How could humans survive cold nights, changing seasons, and eventually colder regions of the world without the thick fur that protected most mammals? The answer was not biological. It was behavioral. Rather than evolving new physical insulation, humans increasingly relied on external solutions. Clothing became essential. Animal skins, furs, and later woven fabrics replaced the protection that evolution had removed. Fire provided warmth when temperatures fell. Shelters offered protection from harsh weather. In a sense, humans outsourced their fur. Instead of carrying it on their bodies, they carried it in their hands. This marked an important shift in evolutionary history. Most animals solve survival problems through physical adaptations. Humans began solving them through intelligence. A wolf survives winter with a thicker coat. A human survives winter by building a shelter and lighting a fire. The strategy is completely different, and it proved remarkably successful. As reliance on technology increased, survival became less dependent on physical traits alone. Knowledge, creativity, and problem-solving grew increasingly important. This transformed the human relationship with nature. Rather than adapting entirely to the environment, humans started adapting the environment to themselves. The loss of fur therefore represents more than a physical change. It symbolizes a broader transition in human evolution. A shift away from purely biological solutions and toward cultural and technological ones. The costs were real. Humans became dependent on clothing, fire, and shelter in ways other animals were not. But the benefits were equally significant. Because once intelligence began replacing physical adaptations, a new chapter of human evolution was ready to unfold. And that chapter would be driven by the most powerful organ in the human body, the brain. If body hair loss tells us anything about human evolution, it is that survival is not always about becoming physically stronger. Sometimes it is about becoming smarter. As our ancestors evolved, one of the most remarkable changes occurring within the human lineage was the rapid growth of the brain. Compared to earlier hominins, later human species developed increasingly large and complex brains. This expansion required enormous amounts of energy, but it also unlocked abilities that few other animals possessed. Humans could plan. They could imagine future situations. They could learn from experience and share knowledge with others. These abilities changed everything. A less intelligent animal facing cold weather might rely entirely on natural insulation. Humans could invent solutions. They could build shelters from branches, hides, and stone. They could create clothing from animal skins. They could maintain fire and transport it from place to place. In effect, intelligence became a survival tool more powerful than fur. The development of tools further accelerated this process. Simple stone tools allowed early humans to process food more efficiently and access resources unavailable to many competitors. Over time, tools became increasingly sophisticated. Spears improved hunting. Knives improved food preparation. Later innovations transformed nearly every aspect of survival. Each technological breakthrough reduced dependence on physical adaptations. Humans did not need claws when they could make cutting tools. They did not need thick fur when they could make clothing. They did not need natural shelters when they could construct their own. This ability to control the environment is one of humanity's defining characteristics. Most species are limited by the habitats to which they are biologically adapted. Humans can modify habitats to suit their needs. From deserts to Arctic regions, people have survived in environments that would otherwise be impossible for a mostly hairless primate. Another key factor was social cooperation. Humans rarely survive alone. Throughout history, communities have shared resources, knowledge, and labor. One individual gathers food. Another builds shelter. Another watches for danger. Together, the group becomes stronger than any individual could be alone. This cooperative behavior multiplied the power of intelligence. Knowledge could be passed from one generation to the next. Skills could accumulate over time. Instead of each generation starting from scratch, humans built upon the discoveries of those who came before. This process eventually produced agriculture, cities, science, and civilization itself. Seen from this perspective, the loss of body hair was part of a much larger transformation. Humans were becoming a species that relied less on biological adaptations and more on culture, learning, and innovation. The body was changing. But the mind was changing even faster. And despite losing most of our fur, evolution did not eliminate hair completely. Some areas of the body kept it. which raises an interesting question. If body hair became less important, why did certain types of hair remain? If losing body hair offered so many advantages, an interesting question remains. Why did humans not lose it completely? After all, we are not entirely hairless. While most of our bodies are covered only by fine, nearly invisible hairs, certain areas retain much thicker growth. The answer lies in a principle that often guides evolution: efficiency. Evolution rarely removes a trait if that trait continues to provide useful benefits. Instead, it tends to preserve what works and eliminate what no longer serves a purpose. One of the most obvious examples is the hair on our heads. Unlike most body hair, scalp hair remained thick and abundant throughout human evolution. Scientists believe one reason may be protection from the sun. As early humans spent more time in open environments, their heads were exposed to intense sunlight. Thick hair may have acted like a natural shade, helping protect the scalp from overheating while still allowing the rest of the body to cool through sweating. In this way, head hair provided a useful compromise: protection where it was needed most, cooling everywhere else. Another important feature is the eyebrow. Eyebrows may seem minor, but they perform several valuable functions. They help divert sweat and rain away from the eyes, improving vision during physical activity. They also play a major role in facial communication. A raised eyebrow, a frown, or a look of surprise can convey information instantly. Human social interaction relies heavily on facial expressions, and eyebrows are an important part of that system. Eyelashes serve a different purpose. These small hairs act as protective barriers, helping prevent dust, dirt, and tiny particles from reaching the eyes. They also trigger protective blinking responses when something approaches too closely. Even tiny hairs can have significant survival value. Then there is hair found in the armpits and pubic region. Scientists continue debating the exact functions of these areas, but several explanations have been proposed. Hair in these regions may help reduce skin friction during movement. It may also assist in retaining scent signals associated with social and reproductive communication. Although these functions are not fully understood, evolution clearly found value in keeping some hair while removing much of the rest. The result is a body optimized for both cooling and protection. Humans did not become completely hairless. Instead, evolution carefully preserved hair where it remained useful. And even today, the story of human hair continues to evolve. Because not all humans have exactly the same amount, texture, or distribution of hair. Those differences tell another fascinating chapter in the story of our species. Although humans are often described as relatively hairless, there is actually considerable variation among people around the world. Some individuals have more body hair. Others have less. Hair texture, thickness, color, and growth patterns can differ dramatically between populations and individuals. These differences are reminders that evolution never truly stops. It continues shaping populations over time. One factor influencing human variation is climate. Throughout history, human populations adapted to a wide range of environments, from tropical regions near the equator to cold northern landscapes. Different environmental pressures can influence which traits become more common within a population. For example, scalp hair shows remarkable diversity around the world. Tightly curled hair may help reduce heat reaching the scalp in hot environments while maintaining airflow. Straighter hair may perform differently under other climatic conditions. These adaptations developed gradually over thousands of generations. Genetics also plays a major role. The growth, density, and distribution of body hair are influenced by numerous genes interacting in complex ways. Small genetic differences can produce noticeable variation between individuals. This is why body hair patterns differ even among members of the same family. No two people inherit exactly the same combination of traits. Modern genetics has revealed just how diverse the human species truly is. Yet despite this diversity, all humans share the same fundamental evolutionary story. Whether a person has more body hair or less, their ancestry traces back to populations that gradually reduced body hair over millions of years. We all inherited the legacy of those ancient adaptations. And evolution is still occurring today. Human populations continue responding to changing environments, diets, diseases, and lifestyles. Most evolutionary changes happen slowly, often too slowly to notice within a single lifetime. But over long periods of time, even small changes can accumulate. The future human body may not look exactly like the human body of today. Just as our ancestors differed from us, future generations may differ from us as well. The story of body hair loss is therefore not simply about the past. It is also about the ongoing process of evolution itself. A process that continues shaping humanity even now. And after exploring all these theories and discoveries, we arrive at a final realization. The mystery of human hair loss may never have had a single cause at all. After exploring millions of years of human evolution, one conclusion becomes clear. There is probably no single answer to the mystery of why humans lost most of their body hair. For a long time, researchers searched for one perfect explanation. Was it heat? Parasites? Sexual selection? Fire and clothing? Or perhaps something else entirely? The more scientists studied the evidence, the more they realized that evolution rarely works through a single cause. Instead, it is often driven by multiple pressures acting together over vast periods of time. Imagine the lives of our ancestors on the African savanna. The climate was becoming hotter and drier. Forests were shrinking. Open grasslands were expanding. Individuals who could cool themselves more efficiently may have enjoyed a survival advantage. At the same time, fewer parasites may have improved health and reduced disease risks. Meanwhile, social preferences could have influenced which traits became more common within populations. None of these forces had to work alone. In fact, they may have reinforced one another. A slightly less hairy individual might stay cooler. That same individual might carry fewer parasites. They might also appear healthier to potential mates. Together, these small advantages could accumulate generation after generation. This is one reason evolution is so complex. Biological changes rarely occur because of a single factor. The natural world is filled with overlapping influences, environmental pressures, random genetic variation, and changing conditions. Human evolution is especially complicated because our ancestors were not only adapting physically. They were also changing behaviorally. They were making tools, building shelters, using fire, creating clothing, developing language and cooperation. The environment was shaping humans. But humans were increasingly shaping their environment as well. Today, most scientists favor a combination of explanations rather than a single grand theory. The strongest evidence points toward heat regulation and sweating as major factors. Parasite reduction and sexual selection may also have contributed. Fire, clothing, and technology likely reinforced changes that were already underway. The exact balance remains uncertain. And that uncertainty is perfectly normal in science. Scientific knowledge is not built on absolute certainty. It is built on evidence, testing, and constant refinement. As new discoveries emerge, our understanding continues to improve. The mystery of human hair loss may never have one simple answer. But perhaps that complexity is the answer itself. Because evolution is rarely simple. And the story of humanity is far richer than any single theory can explain. As we reach the end of our journey, we can look back across millions of years of human history. From the furry ancestors moving through ancient African forests, to the endurance hunters crossing the savanna beneath a blazing sun, to the toolmakers who mastered fire, clothing, and shelter. The story of human hair loss is really the story of human adaptation. Our ancestors did not simply lose their fur. They exchanged one survival strategy for another. Instead of relying entirely on biology, they increasingly relied on intelligence. Instead of growing thicker coats, they built fires. Instead of evolving stronger claws, they created tools. Instead of adapting only their bodies, they learned to adapt the world around them. That transformation changed everything. The hairless skin we see today is a reminder of a much larger evolutionary journey, one that turned a small African primate into a species capable of living on every continent on Earth. And yet, despite all our technology and achievements, traces of that ancient past remain. The hair on our heads, the shape of our bodies, the instincts we still carry. They all connect us to ancestors who lived countless generations before us. So as you settle in and reflect on this long journey through time, remember that every person alive today carries the legacy of those early travelers. Their struggles, their adaptations, their remarkable ability to change. And perhaps that is the most extraordinary lesson of all. The story of humanity has never been about perfection. It has always been about adaptation. With that gentle thought, allow your mind to drift peacefully through the deep past. Back to the forests, the savannahs, and the ancient ancestors who helped shape the humans we are today. Good night.